Hello, everyone! Chapter 6, Learning Target 1. This is Miss Oshier.
And Miss LaHart.
And here we go.
All right, so you are going to get a reference sheet.
Woo! Reference sheet.
Yeah.
It's going to be your best friend.
So basically, this chapter is all about how all the formulas that are on there.
Yeah, you're manipulating the stuff to go with the reference sheet. That's basically it. Okay.
So on your reference sheets, these look like this. Now, just to hindsight, click.
Boom.
That does not, sign of A, parentheses,
No.
A plus B, does not
No.
just equal sign of A plus sign of B.
See, it equals sine of A times cosine of B plus cosine of A times sine of B.
And there's a lot of math to prove all this, but it would take us too long. So just go with the fact that these formulas
Are given to you.
are given to you.
And you're accepting them and saying thank you.
So basically, you have two angles, alpha,
Alpha and beta.
Yep.
Now, we could call the angles 20 and 70, 30 and 50, like whatever. But you call one of them alpha and the other one beta.
Yep.
And you go with it.
Just notation.
Yep.
Okay.
So, listen, people. Are going to have a no calculator for this. Because you should know your exact values of your unit circle. No, you're not going to get a unit circle. You're
Right.
at the big kid land now where, we've graduated from giving you your unit circle. You need to know your values. Okay. So example 1, evaluate sine of 75 degrees without using a calculator. And you might be like, well, that's not one of the ones we know, so
Well,
what the heck?
that's why we need the sum and difference formulas.
That's the point of this. So we know you're basically always thinking about 0, 30, 45, 60, and 90. For
And I mean, you
doing
can
this.
use different ones. You can use bigger than 90 degrees. It's just easier if you use the acute angles, but whatever works.
Absolutely. Quadrant 1 angles are easier, but you can use whatever ones you want to. So we know that 75 is 30 plus 45.
Yes.
Again, we're trying to use the values from the unit circle. You could probably do 135 minus 60, but that would not be a sum one, but I wouldn't do it that way. So we're going to rewrite it as 30 plus 45. And then notice, we're calling this alpha and this beta.
So then it follows suit that alpha is 30, beta is 45.
We're just plugging it in. Now, sine of 30. If you're doing your hand trick, you're figuring out that sine is 1/2. If you're doing your special right triangles, you're saying, okay, opposite over hypotenuse. Whichever method is the way that you do it. So, sine of 30 is 1/2. Cosine of 45, if you're doing it this way, is 1 over radical 2. If you know your unit circle, it's radical 2 over 2. Plus yada, 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 yada. Okay, you're just plugging it in.
Now, multiplying, remember when you multiply fractions, it's just you multiply across, so numerator, numerator, denominator, denominator. Same thing, And then adding, you got to make sure that you have a common denominator.
Now, the nice thing is almost always you will. Almost always, unless we got tangent involved, but almost always you will have that common denominator. So this would be 1 plus radical 3
Well, that's taking its pretty little time to get there.
over 2 radical 2.
Now, there is a problem with that.
There sure is. You cannot have that radical on the bottom.
No. So, remember, the easiest way, like technically you can multiply by 2 times radical 2, but the easiest way is just multiply by that radical.
You just want to get rid of the radical. If this were 2 plus radical 2, totally different story.
Yep, we would have to use conjugates. So anyway, so here hopefully is, look at, right on it.
There it is.
In the top you would distribute. Radical 2 times 1 is radical 2. Radical 2 times radical 3 is radical 6. In the bottom you would do, radical 2 times radical 2 is 2, so 2 times 2 is the 4.
Boom.
And that's all you can do. You cannot reduce that, remember, because it's not, they all aren't reducible.
Right, they all don't have a factor of 2. And you might think that they do, but these are radical 6 and radical 2, not 2 and 6.
Yep.
Don't do that.
So there's your first one.
And then again, this would look different if you had radical 2 over 2 here, but you would still end up at the same answer in the end.
Yep. Okay.
Okay.
Differences.
Okay, difference. Exact value 165. So what subtracts to make 165? So this is where you're going to probably use something bigger than quadrant 1.
Yep.
So 210 minus 45. You might think of another one, but that's the one that we're going with.
Yep, and there's multiple answers for this. A lot of people can do different things as
you
long
got
as
all
it,
these
whatever you subtract equals the angle that you want.
Right.
You're
Not
good to go.
negative the angle.
Right.
Not 45 minus 210, notice.
Yep.
Okay. So we plug that into the difference formula, and then we've substituted in
Now,
appropriately.
Because 210 is a bigger angle than, your 0 to 90, I kind of adjust it to the first quadrant angle. So I know that in 210, cosine is negative.
Yep.
Okay.
It's in this quadrant.
And the reference angle of 210, the difference between the angle and the x-axis, is 30 degrees.
30.
So cosine of 210 is the same thing as negative cosine of 30, if you're using your unit circle. Same thing with sine of 210.
So Here we go. So all these values, again, are coming from that cosine of 30, but it's negative. Cosine 45. And we always bring it back to the quadrant 1 angles because they're usually the ones that you can memorize, and also they have the hand trick work.
So you just got to remember to watch your signs. And again, we're doing multiplication, which my animations seem to go very slow.
It's okay. It's giving them time.
Okay, so you can write it down. So again, you have a common denominator, so you can combine them.
And now be careful here. It's negative radical 3 minus 1.
Yeah, clean it
Be
up.
careful.
Clean it up.
And then that's not okay. So multiply by radical 2 on top and bottom.
Here it comes.
Distribute that bad
Oh,
boy.
she's going to she's like, I have no time for this.
Negative radical 6 minus radical 2 after you distribute the radical 2 through over 4. A lot of these look similar because a lot of these, like cosine and sine, are basically just the opposite for certain angles. So they're going to look very similar.
Okay.
Okay.
Ooh.
Difference formula. To find the exact value of tangent, pi over 12. Whoa.
That's a radian measure.
It's a radian measure, people. It's fine. If you feel more comfortable with degrees, switch it to degree. So it's 15, 30, 45. Woo!
Oh, that's a good one. 45. Did I use that one?
Nope. 16,
I used
45.
16 minus 45.
That was a point that we were trying to make to you people. Again, anyone that you want to use.
As long as your angle is the right arithmetic,
Correct.
you're good to go.
So tangent of 60 minus tan. Okay, we're using that formula. So we're just plugging this into the formula given. Tangent of 60 is radical 3. Tangent 45 is 1.
Oh boy,
tangent
here we
60
go.
is radical 3. Tangent 45 is 1. It's really beneficial to know your tangent.
Okay, now a lot of stuff popped up. So that first situation is us just plugging it in, plugging the answers in. Next situation, 2 things pop up. So we're looking at that, but we have a...
Ignore this right now. Just focus here.
Yep.
Focus here.
So in the bottom of that fraction, we have ourselves a radical, and it's a binomial. So this is a different issue.
Right. So all that happened between here and here is we multiplied the 1.
Yep.
So boom, okay, great. And now as Miss LaHart said, the 1 plus radical 3, you can't just multiply top and bottom by radical 3 because it's not that easy. Like if you did it, you're still going to have radicals, you'll see.
Yep.
So you have to do the conjugate, which you learned.
Ooh, conjugate.
It's the same thing with the difference in the middle.
Yep. Because what happens is when you go to distribute, this is me distributing the top.
Oh, the top. I thought
think.
it was a plus and minus mistake. I was like, whoopsies.
Nope. So I distributed at the top over there. First, outside, inside, last. Simplified what I could.
So pretty.
Okay, now
The nice thing about the bottom is that it's just going to be first and last because the entire purpose of the conjugate is to get the outside inside part. If you're foiling the double distribution, that part's going to cancel out every time. It's like difference of perfect squares.
Yep.
When you do this, it's difference of perfect squares. So you're going to end up with this number and that number. So 1 times 1 is 1. Radical 3 times negative radical 3 is negative 3. 1 minus 3 is negative 2.
boom. So honestly, the hardest thing for this chapter is probably remembering all your radical rules.
Yep.
Okay.
Sometimes you work backwards. So for instance, hey, what is this? So we might say, well, look at your reference sheet. That's a sum. That's a tangent sum formula. So you work backwards and you say 80 plus 55 is 135. So they're really just asking us for tangent 135, which is definitely a 45. So that's 1, and it's negative because it's in the second quadrant.
Boom. So it's -1.
Boom.
So that's working backwards.
Yep. You will eventually be given a calculator, eventually, and that helps a lot with this kind of stuff, but we need you to understand how to do this on the unit circle.
Exact values. And your calculator won't give you exact values. Oh, look, one more just to drive it on home.
So I'm seeing sine, cosine, minus cosine, sine, so I would literally just go to my reference sheet and say, oh, that's that one.
That's sine A minus B, so you did 4 minus 18, which is sine 22, and then that one's not a reference angle, so you would have to...
Boom. It was a radian question, so you need to put it in radians.
Oh, so it was just equivalent to... Ew, 11 pi over 90.
Yep. And it says write the expression as the sine of a single angle, so you just write sine of that.
That's all we're looking for.
It's not asking for the value. It's saying write it as the sine of an angle. There you go. Boom. Learning Target 2 coming up. Have a great day. We'll see you in class.